today we're going to talk about the dirty cow vulnerability. Okay? And this is a special case of the risk condition. We talked about the risk condition, okay? And we have seen some example of risk condition. So this is a very timely attack and very closely related to risk condition. Okay? So we're going to talk about this attack. In the last week, we talked about the overview of this attack, and today we're going to really dive into the technical details and to really understand and how actually people can write code and to launch such attack. Okay, so and I will give you my code. Okay, so you can use my code to actually to modify some of the protected file. Okay, for the file that actually you can modify is really just a dummy file. Okay, it's really not that important. So but that's what the code I'm going to give to you. And I'm going to ask you to basically to run my code and to see how the vulnerability can be exploited and to actually corrupt some of the protected file. Okay? And then after that, I will ask you to choose a different file so you can gain the root privilege. The goal is to really gain the root privilege, not just to corrupt some of the protected dummy file. Okay? I'm only use dummy file as an example. Okay? So as I said, this is a case of risk condition, okay, and this affects all the Linux-based operating system, okay. Android is part of that, so this attack also works on Android, okay. And the problem existed since 2007, so you can see that's about 9 years. The problem has been there, okay, and now just recently discovered, and back in October and this year, okay. And we also tried on some of the Android device, quite recent one, and they also work. Okay, so it's very, very severe. So one thing I want to make sure is what you learn from this, you can only apply to the VM. Okay, so never try to on some real production system. The chances are they may be successful. Okay, so I don't want to get into trouble, but I do want you to know the problem because it's a perfect case of risk condition. We have seen one type of the example, but this is kind of different. The pattern is very different, okay? And this one is in the kernel level, okay? The one we see is actually the user level, and this is done at the kernel level. And if kernel level, a lot of things are shared, okay? If you can create a risk condition, and you're going to see, and that you can actually become the root, okay? So I'm going to do a demo first, okay, to show you and what we can do, okay? So I already have written some of code, okay? So the one that I'm going to give to you is this code, okay? The one that I actually put. So, and I'm basically asking you to modify the /zzz file, which is dummy file, okay? So, but I'm going to demonstrate this one, okay? I'm going to actually use it to corrupt the /etc password file. I want to gain the root, okay? So I created actually a new user. Okay, so if you go to look at the file at the bottom, and you can see I created a new user called a test. And this user is not a super user. You can see the UID is still 1001. Okay, so now if I do the login to this user, okay, and you can see I'm just a normal user, right? If you type ID, okay, and my UID is still just normal, okay. Now I'm going to run the exploit. Okay, so I'm right now in this folder, and I'm actually using this dirty cow and to modify the password file. Okay, so if I run this, it's only take a few seconds, and I just stop. Okay, and now I have to log out. Okay, so I'm logging out, and you can log out from the entire Linux. I'm just to make it faster to do this SU. Then I'm SU to test again, and you can see I got a pound sign. Okay, so simply by running that code, I gain the root privilege. If I type ID, and you can see my UID becomes 0, and of course I didn't change my GID. I could have changed my GID, but my UID changes. So what I did is I only simply modify the file. Okay, the password file. If you look at, let me exit from here. And if you look at this line, used to be the UID field used to be 1001, then become 0. Okay, and you know what 0 is. And if you have UID 0 and you are root. Okay, so, and obviously the user test account cannot modify this file. But simply by running that exploit, and you are able to modify that /etc path file. Actually, you can modify any file you want. Okay, and this just demonstrates that, and you can actually cause damage. You can become a root. Okay. So I will explain how that happened. What is vulnerability? Okay, so you can fully understand the problems. Okay, and then you're going to repeat this in the class. And this actually relates to the mmap. Okay, now mmap allows you to really map a file to the memory. Okay, so you can see I have a file here. Okay, and I actually using mmap to map this file into the memory. Okay. So once I map into the memory, then the reading and the write to the file just like the memory operation. Okay, and you can see here I'm actually open this file. First, I'm going to open this file. This file is a ./zzz file. Okay, and this is just my own file. I'm using this example. Okay, so this is just my own file. I'm open this, and that's typical. But then after that, I actually map this file. Okay, into a block of memory. Okay, and you can see this file content now is going to map to the memory. Okay, and the return value is going to be the address of this if the mapping is successful. Okay, if the mapping fails, and then you don't get anything back. Okay, so one thing you need to pay attention is that these are the permission on the memory needs to match with this one. Okay. So if this file is only read-only, and you cannot map the memory as a writable, okay, because then the permission does not match, and your mapping will fail, okay. But here, I'm going to open this file because this is my own file. I can open it for read and write, and then when I map to this one, I want to see read and writable, okay. And now after that, I get this memory. Now, in order to write to this file, now I can just simply just do this. I'm just memory copy. Okay, you can see I'm just doing memory copy. I'm copying this content and to this address. Okay, and so here I'm copy this write to the file. Okay, I'm actually copy this content from the map and I'm copying this from here to here, okay? So here I'm reading from here. I'm reading from the map and to put it in my buffer, okay? And now you can see that's pretty much just like a memory operation. And whatever you write to here, and once you close this, and the content will be returned to that. Okay, that's making this writing just the memory operations. There are many other of the applications, okay? But this is one of the low-level mechanism that is supported by the Linux system. Okay, so there's nothing wrong with that. Okay, there are protection. If this read-only, you can only read. If this read-writable, and you can write. So if you change this to the /zzz file, okay, and now first you're going to fail here because you cannot open a file for write. Okay. So if you open that for read, and then here you cannot have the write. If you have a write, and the system is not going to allow you to map a read-only file to a readable and a writable region. Okay, so there's nothing wrong with this. Now, what if we want to map a read-only file? Okay, and this is things get interesting. Okay, so here I'm mapping a read-only file. Okay. And here you can see I'm mapping this read-only file. Okay, so I'm allow you to actually type any file names. Okay, so and I have to make sure and this is read-only. Okay, if the file is not read-only, and I won't be able to map to that. Okay, so now after I do this, okay, if it's read-only, okay, and if I still using the memory copy. Okay, Now, if I use memory copy to read, there's nothing wrong. Okay? But if I use a memory copy to write to this, read only the area, and I won't be able to write to that. Okay, for sure. I mean, the memory is read only. You cannot write to that. Okay, so that's a typical behavior. But Linux allow you to really to write to a read only area. If you tell the system, I'm only use this as my private copy. I'm not actually write this to the file. I'm just my private copy. Okay, if that's your intention, and you can actually do that, you can write it to a read-only area, but whatever you do is only going to be stay within your process. Okay, it's not going to be affect the file. It's not going to be affect the other process. Okay, so now to do that, you need to map this to this map private using this option. Okay, and if you say I'm going to map shared, and you won't be able to do that. Okay, so I'm going to map this to the map private. Okay, so the system knows, and this is private. And then you have to kind of use the file operation and to write to that. Okay, and you cannot use a memory copy anymore. Okay, so you will have to map this and open this memory. This is actually the mapped memory, and open this and get a file descriptor. And then you can use that file descriptor, and you can see I'm moving my pointer and to map +5. So I'm going to write to the 5th position in the file. Okay, so and then I'm going to write to this, and I will do a check to see whether my write is successful or not. Okay, and then I can only read. I can also read, so I can do the else seek, and then I'm going to read and the 29 bytes and from that area. Okay, and you're going to see that actually my write can be successful, but it's not going to affect the file. Okay, so I will show you that the behavior of that. So I have this the mmap write. So I'm going to just write. I create a file in the root folder, and you can see my actually the write succeeded. Okay, and I actually read this from. And the file itself just contains a bunch of 111s. Okay, so that's the file. Okay. So but if you can see after I write to this file, you can see after I write to here, and then I read it out, I do get actually the updated content. Okay, but this doesn't affect the file actually. It's my own copy. Okay, you can think about I have this virtual file now. Okay, and I can write to this virtual file, but this is not going to affect the actual physical file. Okay, so this is my own copy of the file. Okay, so and if I can do this, and so even for my own file, okay, I also have another file in my own current folder. If I just write to this, and you can see this looks like my write is successful, and when I read it back, I did read the updated content back. Okay, so these are what I added to the content. But if you just look at my file, and it's just a bunch of twos, okay, and it's not modified. Okay, so it doesn't affect the real file. I can even do this for any file I want. Okay, I can do this. You can see I'm trying to write to that /etc path file. Of course, I don't have permission to write, but you're going to find out I can map that file into the memory. I can write to the memory. Okay, and after I write to the memory, if I read it out, and this is first row. Okay, and you can see some of the contents injected. But if you actually look at that file, and that's the first row. Okay, and it's not modified. Okay, so this is the kind of behavior they allow you to have your own private copy. Okay, now what happens? Okay, so this is the behavior, but it is what that actually happens in the kernel that causes a problem. Okay, so now what happens? So here that's a file. Okay, and it allows to map to this memory. Okay, this is memory. Now it said I want to write to this memory. Okay. Now what the system is going to do is going to say, I'm not going to allow you to write this memory because this is a read-only memory. Okay. I'm going to let you to have your own copy. Okay. What the system is going to do, the system is going to actually create another block of memory, okay, which is a copy of this block. Okay, and let you to write to this copy. Okay, so instead of letting you to write this copy, but it lets you to write this copy. Okay, but the problem is your address. So when I say I'm going to write to this address, my address is already given, 0xAABBCCDD. Now, before I don't want you to write this, but I will let you to write to here, but your address is already AABBCCDD in your code, right? So how do I force you to write this region? What do you think? How can the OS kernel, after actually duplicate the content from here, create a new region for you? How can the OS force you to write to this without changing your address, without changing this address? You're still writing to this address, but then you suddenly write to here. How did the OS do this? Remember, this address space, they are just virtual table, right? They're just virtual address, okay? So what the system does is actually, so this block of memory, this is a virtual space. Okay? So the virtual space actually maps to the physical space. Okay? So you actually map to the physical space. Now, when I do the copy, I don't copy from virtual to virtual. I actually create a copy in the physical space. Okay? So this is the physical space I'm copying to that. Okay? This is the identical copy now. Now, in order to not to change your address, now I'm going to change that mapping. Okay? And this mapping is done through the page table. Okay? That's a translation between the virtual and the physical. Right? The OS basically changed the translation. Okay? Now this block just mapped to here. So the application is still writing to that virtual address space. The address is still the same, but behind the scene, and what is written is written to that physical DAD. It's different area. Okay? So now you're actually not writing to that area. You write to your private copy. This is your private copy. That's why I can end up writing to that area. But whatever I write to this area doesn't affect the file, because the file is actually mapped from there. Okay? So, and now this is the first part. Okay? Now, remember this write operation is going to actually lead to this 1 and 2. And it's going to lead to this 2 action. Now, these 2 actually are not atomic. Okay? So, because these 2 actually involves a lot of operation, especially the first one. Okay? And it involves a memory copy. And so, these are not atomic. That means right after you finish 1, your process can be interrupted. Okay? And now somebody else can do something. Okay? And then you can resume 2. So 1 and 2 can be divided into 2 cycles. Okay? Now, this is where the problem can come. Okay? Now, there's another system call called M-Advise. And this one basically says, I don't need that memory anymore. I don't need my private copy anymore. Okay? So change me back to the master copy. Okay? So now this one points to here. Okay? Remember there are 2 copies here. Now this is a private copy. Now you can tell the system, I'm done. Okay, I'm done with this copy. Okay, and let me go back to this master copy. Okay, when you issue this one and you tell them I'm going to starting from this one, the size of 100, and the option is I do not intend to use that anymore. If you do that, then the OS is going to actually map it back. Similarly, just do the remapping. Okay, change the page table and map it back. Okay, and this is operation 3. Okay, so now I want you to tell me where the race condition is. This is where the problem is now. Okay, operation 1, change mapping to private copy. Operation 2, write to the memory. Operation 3, change it back. Now normally we are going to do the 1 and 2 and then do the 3, okay? And 1, 2, 3, 1, 2, 3. And that's ideal case, right? And you try to write and they let you to write to the private copy and then you say I'm done, okay? And you change it back. So 1, 2, 3, okay? And this is nothing's going to wrong. But as I said, this is not atomic. Okay, now I want you to tell me, okay, tell me a scenario where this is write protected, okay? Now your goal is you want to write to that area, okay? If you just write to this area, it doesn't affect the file, right? Remember, it doesn't affect the file. But if you can end up writing to that file, that can affect what this area map to, okay? If it's read-only file, that means that file and could be just read-only to you, could be a system file, / it is a password file. Now, if you can end up writing to that area, and that can actually eventually lead to the actual corruption of this protected file. Okay? So now tell me, what is the sequence that you would actually create so you can actually end up achieving this goal? The only way to achieving that goal is you got to be able to write to that file. But as soon as you start to write to this file, okay, and the system is going to make a copy for you, so you're going to actually eventually write to your own copy. So there's no way you can just directly write to that memory. But now you know that's a race condition. Okay, and you know this change from here to here is not atomic. Okay, now think about what would you do? What would you do so you can somehow actually write to this area, not into this area? Yes?
Could we, after the program executes step 1, if there's a context switch
Yes.
to another program we control, could we have that program give complete unadvised and try to execute step 3?
Very good, very good. So that's what we need to do. Okay, very, very, very simple. So what you need to do is to be able to inject 3 between 1 and 2. If you can do that, let's think about if I can do this step 1, okay, let's remove this now, okay. Now step 1 says I'm going to, when you say I'm going to write, the step 1 is going to say I will map this to here. Now if you continue to write, then you're going to write to this area. Okay? But now if you can find a way to inject 3 right after 1, now what does 3 do? 3 is going to discard this part, change it back. Now you're going to write. Okay? But you didn't know that actually this is changed back. Okay? Now system will write to that area. Okay? Because before this, the system already did the check. Right? It's checked, oh, this is a private copy, and you should not write to this region. So check is already done before this. That is what lead to 1. Okay? To copy this to here. Okay? But before this actual write happens, and you point it back. Okay? So you end up writing to this area. And that can lead to the writing to a protected file. Okay? So the idea is very, very simple. You just find a way and to get action 3 in between. Okay? So as we said, you cannot deterministically do that. okay, because this is depending on the schedule. Okay, as long as 1 and 2 are not atomic, there's a chance, there's a window. Okay, this is the window that we are looking for. So all we need to do is to run 2 processes. One process I'm keep writing, and I know this writing is going to trigger 1 and 2. On another thread, I keep saying I don't need S anymore. Okay, so I'm keep doing this for 3. Okay, and hopefully, and at some point there going to be 1 and 3 and 2, and then I'll be successful. Okay, so that's what we're going to do. Okay, and write 2 processes, and to do that. Okay. So I have already explained that. So I'm just going to show you the code. The code is extremely simple. You can see I can fit everything in this one slice. Okay. So if you look at the file here, okay. Now, what I did is I'm just open this file. This is a protected file. Okay. So I don't want you to corrupt any useful file. I'm just creating a dummy file. Okay. So the target is to modify this file, but this file is in the root directory. Okay. And if you create this file and make sure this is only readable. Okay. So if you look at the mic. So if you look at my system, you can see the /zzz is actually owned by root but read only. Okay, you want the file to be read only. Okay, so you need to be able to open that for read. Okay, so now we can open this. So this one is going to be okay. I can open that. Now I'm going to map this to memory. I need to specify the map private because the map private is going to trigger step 1 and 2. Okay. If you don't specify as a map private, okay, and it's not going to trigger that. And then I will make sure this is only read, because as I said, this need to match with this. If it doesn't match, your mapping is not going to be successful. Okay. Now after that, I get this mapped region. Okay. Now the next thing is I'm just going to create 2 threads. Okay. The thread 1 and thread 2. Okay. So and don't worry about this. Wait for the thread to finish. They never finish. Okay. They all infinite loop. So this is going to actually start this 2 thread. Okay. Now if you look at this thread, okay, so this is the second thread. Well, the second thread basically is just going to in a loop. Okay. And what it does is basically else seek to the map plus offset. So that's your target area. Okay. So and you can choose that wherever you want to actually modify. So and then I'm going to write to that area. Okay, so this write is going to trigger the action 1 and 2. Okay, copy and write, copy and write. So I basically keep doing this, copy and write, copy and write. Okay, so and obviously if I don't have the other thread, I will always just copy and write and to my own memory. Nothing's going to affect the file. But I do have another thread. Okay, this thread. The only thing I do is I'm going to tell the system I don't need this anymore. Okay, so that's going to trigger the action 3, and I'm just going to let them run. Okay, 1, 2, 3, and they run. Okay, anytime 3 is injected between 1 and 2, and you'll be successful. And you're going to find out it's very easily. You can see when I do the demo, I just wait for just a second. Okay, maybe it doesn't need a second. Okay, so and that's all you needed to have these 2 actual process running. Okay, and to be able to actually cause that race condition. And when that race condition is satisfied, and you would be able to write to this area. Okay, your write will be successful, and to that copy, to that mask copy, not the duplicate copy. Okay, and that will actually cause this file to be modified. Okay, so this is basically how this works. Okay, the idea is very simple, and I'm going to give you this piece of code. I'm going to let you to run my code and to get a sense of how you can actually compromise a protected file. Okay, that was step 1. Okay, so and step 2, which I think we will have time, and I'm going to ask you to gain the root privilege. Modify my code and slightly, and then you can gain the root privilege. Okay. And this is the header file. Okay, so that we need to include some of the headers so we can compile. Okay. And when you compile, just make sure, always remember, you need to use this -L and a pthread, because that library is not actually included by default. We do use the thread. Okay, so that's why when you compile, just always remember -L pthread. Okay, and then other things just typical. Now, we just show you how you can do corrupting this /ZZZ file, right? This dummy file. And now you can either think about what are the real damage, right? What I just showed you is /etc password file. So every user has this record in the account. Okay. Now this is the file that we use in the race condition lab, right? We actually create add a new user, okay? Because for that actually attack, and we can actually add some content to the file. But this one allows you to modify some content, so that will be much easier. So all we need to do is really just change this to 00040. Okay, just make. You can put 10, it's fine. Okay, so 40, so you don't need to actually mess up for the rest of the field. Okay, and that's going to give you the root privilege. Okay, that's all you need to do. Okay, and there are many other things you can do. Okay, so as I said, this attack work for Linux. Okay, unless your Linux is patched in the last 3 weeks, unless. Okay, otherwise, and all the Linux system is going to be actually affected. The Android is going to be affected as well. Okay, so we're actually trying to develop a lab, and that we can actually work on for one of the lab we're going to work on in the next few lectures is going to be the repackaging attack. Okay, so repackaging attack is you download an application, okay, and which is a popular application, for example, Angry Bird. Okay, so and you actually change this. You repack it, add your own code, malicious code, into this new this app, and it still says Angry Bird, and now this time it's free. Okay, you upload to some marketplace and wait for others to download. Okay, this is a typical attack. Okay, and we're going to work on that. Okay, so in the past, this code doesn't do a lot of damage. It's only wipe out your contact list, your friend list. Okay, now we are thinking and add the dirty cow in that code. Okay, we haven't figured out how to do that though. So we're thinking about add that dirty cow code in this piece of code. So now if you download the Angry Bird, and your phone is going to be rooted by this Angry Bird, okay? Because dirty cow has the capability to root your phone, and now the attack is going to take over your phone. So this is very, very serious, okay? So and this repack attack is very common. A lot of people download this app and not knowing this app is already modified. Okay. Now, if somebody just put the dirty cow code inside that actual repackage the app, and your phone is going to be compromised. Okay. And we're going to try to see whether we can develop that part before we do the repackage lab, and that's something we'll do in the next 2 weeks. Okay. So, but we'll see. Okay. Hopefully we get that done. But if not, then we can still wipe out your friend list. That's a damage. Okay. But I want this dirty cow damage. Okay, so this way I'm going to hand it over to you guys, okay? So now what you can do is you go to Piazza, okay? So this first step, I do have a 2-step. So let me just show you, there's 2 steps here, okay? And hopefully you finish this step, okay? And quickly, because you don't need to do anything. You just download my code, compile it, and try to see whether you can modify the ZZZ file, okay? That's first step. Okay, so download this from Piazza. I actually post to both graduate student and undergrad student, and you should be able to get that. Okay, and then you need to create a file called ZZZ or whatever the file name. Okay, and and you put some content inside. Okay, and then trying to see whether you can modify the file. And of course, if the file is set up correctly, you only have read permission. If you try to do this one, you won't be able to write to the file. That means the file is protected. Okay? But we want you to use dirty cow exploit to write to that file. That's the goal. Okay? So this you cannot do, but you should be able to use my code, okay, and compile it and get a binary and run a binary as a normal user, and then go to look at the ZZZ again. Okay? So And let's do this first. Okay, hopefully 10 minutes you can do that. If you are done with this, and what I'm asking you to do is to, now instead of using the /zzz file, I'm going to ask you copy this /etc password file. Don't directly work on this file, okay? So if you directly work on the file, you may mess up the file, okay? And that may cause you trouble, okay? But so copy this to zzz file, okay? And then still work on that. Once you see that your attack is successful, now you can change the /zzz to the /etc password file, and to see whether you can actually be successful. For these slides, there are some information that you need, okay, and to help you to finish this. In order to not to mess up your system, take a snapshot, okay? And I did take a snapshot before I work on this myself. Take a snapshot, and if you don't know how to take snapshot, so there's a one here, okay? So snapshot here, if you go to your VM, you can see there's a snapshot here, okay? And you click on here, and there's a camera, and just take a snapshot. That's going to preserve the current state of your computer. Now, if you mess up your system, you can always roll back, okay? So you don't need to reinstall the VM again, okay? So you can see actually a day ago, before I do this, I took a snapshot, okay? So just make sure you do that. And now after that, what you can do is, your goal is to achieve this, change this from this to here. And this piece of code basically help you to identify where this string is, okay? And you can see after I map to this, I'm calling this a string. String is to look for a substring, okay? I'm basically, from the starting of the memory, I'm looking for this string, okay? I'm going to find where that is, because I know in the memory that string is somewhere. I need to find the location. Once I find the location, I will calculate the offset, which is the start minus the beginning of the map, and I get this offset. Okay, and then what you can do is when you actually write to that file, you got to start from this offset. Okay, and this helps you to identify that offset. Okay, so remember in the code that I have, you can see there's an offset I have. Okay, for this code I started with a constant, but now you need to make sure you start with that calculate the offset. Okay, the content you need to write to that needs to be whatever the information you want to write to. Okay, and do create a user. Don't try that for the seed user. Okay, and I tried that for the seed user myself, but I messed up my account. Okay, my attack was successful, but a lot of these my desktop setting got messed up. I don't know why. So unfortunately, I had actually the screenshot. Okay, so create a new user. Okay, just do the sudo add user test. And it's going to ask you a bunch of questions. Just keep hitting the return. Okay, you don't need to type anything, and a new user will be actually created.